Solve number 10. A cutting plane divides a sphere into two zones with areas 24 pi square inches and 72 pi square inches. Find the area of the section formed. Okay, so let's write the given. Okay, so let's draw the sphere. Yes. And the cutting plane. Somewhere, not specific, not necessarily at the center. Okay. We do not put the cutting plane in the center because the two zones that would be the result of the cut is actually not equal, so the cutting plane doesn't actually divide the sphere evenly into two. Okay. Hindi siya masyado, it's not really clear. Anyway, the upper zone, okay, let's label this one Z1. This one is the bigger zone, so let's name it, let's have it 72 pi square inches. And of course, the lower part, Z2, is equivalent to 24 pi square inches. Okay, so required, okay, is the area A. Okay. So let's locate that area. It's somewhere here. Okay, it's the cross section. That's the area of the cross section that is formed. Okay, so solution. Okay, so the two zones, okay, when combined together is actually the area of the whole sphere. So we say that Z1 plus Z2 is equivalent to the SA of the sphere. Okay, so let's add. So 72 pi plus 24 pi is equivalent to the surface area of the sphere, which is 4 pi r squared. We do this to determine the radius of the sphere. So 96 pi is equivalent to 4 pi r squared. Okay, so solving for r therefore is equivalent to the square root of 96 pi over 4 pi. Okay, which gives us a value of 2 square root of 6. Now let's redraw the cross section of the sphere and showing the cut part. Okay, so this will be the cross section, and this is supposed to be the cut part of the part where the cutting plane passes through. Okay, so this one will be the H1, and of course this one will be the H2, or these are the two heights of the spherical segments. Okay, so we determine H1 first. Okay, we do that using formula. Z is equivalent to 2 pi RH. Okay, so 72 pi is equivalent to 2 pi times 2 square root of 6 times H. Okay, so H therefore is equivalent to H therefore is equivalent to 3 square root of 6 inches. Okay, or that's H1 rather. Okay, so 3 square root of 6 inches. Okay, so take note that this is H1. Okay, somewhere that here is the center of the sphere, and this one is supposed to be our R, and this one too. Okay, so we need to find the X so that we can determine the radius of the small circle, or the radius of the cross section. that is formed by the cutting plane. Okay. So solve for x. So you have x therefore is equivalent to our h1, 3 square root of 6, minus our radius, which is 2 square root of 6. So this gives us x therefore is equivalent to square root of 6. Now to solve for the small r, so we use Pythagorean theorem. So that would be the square root of, okay, r. So that's 2 square root of 6 quantity squared minus square root of 6 quantity squared. Okay, so that gives us an r which is equivalent to, okay, r therefore is equivalent to 3 square root of 2 inches. Okay, now the area therefore of the cross section, or the small, which is the small circle, is equivalent to pi times 3 square root of 2 quantity squared. Okay, so area therefore is equivalent to 18 pi, or approximately equivalent to 56.55 square inches.